All right, so the equation we're talking about is y times y triple prime minus sine x equals y prime.
Yep.
Okay, and we're trying to classify this thing, right? So basically just put a name to this beast. You don't have to solve it. So what am I seeing here that's kind of... What am I looking at? What are important things I see?
Order.
Okay, so I see this y triple prime, right? I see a y prime also and a y. So that tells me that I have, at the very least, a third order. Right? Why is it third order and not also first order?
Because it's the highest order, not the orders of every single one.
Yep, good. Find the highest derivative present. So I have a y triple prime, hence third order. Okay. What else?
It's non-homogeneous.
Non-linear.
Okay, so those two terms, I need to pick which one goes first. So the first thing I need to try to do is classify...
Oh yeah, non-linear.
Non-linear, non-homogeneous.
Okay,
Is
so
it constant coefficient?
hang on. So
chill, everybody, chill.
this is non-linear, which means that you do not get to pick constant coefficient, this is not an option because constant coefficient is a modifier for the word linear. Does that make sense?
Mm-hmm.
So linear things can be constant coefficient, but non-linear things can't be constant coefficient because that doesn't mean anything here. So the other one is this homogeneous versus non-homogeneous kind of modifier. That is also a modifier of linear. And thus also here is not a choice that I get to make. Now, there is very specifically a first order non-linear homogeneous ODE, which is very specifically this thing y prime is f of y over x. But in that case, all those modifiers go together. That is one classification of that very specific thing. Oops, I said nonlinear homogeneous and I meant non-homogeneous. Oh no, I meant homogeneous. I don't know why I'm writing non-homogeneous. So in that one case, you can use the word homogeneous to describe nonlinear. But we wouldn't say nonlinear non-homogeneous because I also wouldn't say that something is nonlinear not Bernoulli. Does that make sense?
Mm-hmm.
And so in this case, once you've said it's third order and nonlinear, then you don't need to pick whether it's constant coefficient or homogeneous, non-homogeneous, because it can't be either of those things. Those classifiers only make sense in the linear case. Does that make sense? So I would say this is a third order non-linear ODE and call it a day.
Not adding non-homogeneous or homogeneous because it's non-homogeneous and it doesn't make sense to just not say it, right?
It's not, so it's not linear and not linear, the homogeneous,
doesn't
non-homogeneous distinction is something that linear equations have.
Okay.
In this case, the constant coefficient thing is also a distinction that only linear equations have. In this case specifically, like, y is apparently one of the coefficients, but also y cubed is one of the coefficient, or not y cubed, y triple prime is also one of the coefficients. So because it's not linear, I don't even know which things are coefficients and which ones aren't.
Okay.
Does that make sense?
Yes. The constant coefficients also, like, that just means that anything basically that isn't like another y, right?
So what that means very specifically, right, that I have
It is linear.
a number times y double prime plus a number times y prime plus a number times
I
y.
could do shock cord. Oh, sorry. I was talking to someone else.
Equals maybe some function of x.
So it can't be another x? The number can't be another x? Because we've seen that before.
Yeah, so the numbers could, if the numbers, in this case, right, that I'm talking about, if these guys, the coefficients on y double prime, y prime, and y, if those aren't numbers, then it's at least not constant coefficient.
Oh, okay.
What if they're ones, which would just mean nothing, right?
That's
Would it
still
still be constant coefficient?
Yeah, ones are numbers.
Right. For now.
Even zeros are numbers. Right, so if one of those things was zero, it would still be linear constant coefficient. Does that make sense?
Mm-hmm.
So this thing is a second order linear, and then because it's linear, I can say it's constant coefficient. And then if f isn't zero, it's non-homogeneous ODE.
Okay, right.
And that really is assuming that f isn't zero. At least not identically. Does that process kind of make sense?
Yep.
Okay,
Yep.
cool. Okay, I also should add that I would not say that something is second order linear non-constant coefficient.
You just don't add that.
Yeah, I just wouldn't add that modifier, right? Like, so if I had x squared y double prime plus 3y prime plus 4y equals x cubed.
You just wouldn't add that it's a...
Yeah, I would say this is second order linear, and then this one is specifically, well, the constant coefficient thing, it doesn't have constant coefficients, so I just wouldn't put that in there.
It's second order linear, non-homogeneous ODE.
Perfect. Non-homogeneous ODE. And on this one, I wouldn't count it against you if you said it's not constant coefficient.
But it's hard to say, so...
Yeah, exactly. It gets...
This is a Twallenhode.
Yeah, that's a Twallenhode. And you don't have a general technique for Twallenhodes. Right?
So if you give it to us on a test, we just say, Jeff, how about we do a different problem?
I mean...
Yeah, what if I made this constant coefficient Twallenhode? Then Walk-Lynchode. Then I can solve it for you, Joe.
Yeah, I mean, in this case, I don't have a technique for that is a perfectly valid option. There are far more differential equations that we don't have techniques for than there are that we do have techniques for. Like, if you pull a random differential equation out of a barrel, it won't be solvable, not by techniques that are known. It will have a solution, probably, assuming some kind of nice things about it. But we won't be able to find this solution exactly using a technique that we know. But if you pull a spring out of a barrel, then we can tell you what the solutions look like.
What a fish.
If you pull a fish out of a barrel, you should put it back. Unless you intend to eat it.
So the second part of that question, part B, is non-homogeneous because it contains the 84 secant x, right?
Yeah, so the second part of that equation, oops, I can just do this.
So as it is, it's homogeneous, but no. Because
Well, yeah, so homogeneous depends on it being arranged appropriately. So that equation is 3y double prime plus 4y prime minus 17y plus 84 secant x.
But like, so as it is, it's homogeneous. But
it's not because it's non-linear. And non-linear,
Wait, hang
you
on.
have to say it.
Okay, so if it was nonlinear, you would be correct. However, this thing is linear. So keep in mind that all of these are up to algebraic rearrangement. So you can take this thing and rearrange using a little bit of, maybe algebra is even an overstep. It's more like subtract some stuff. So you can rearrange this into 3y double prime plus 4y prime minus 17y equals minus 84 secant of x.
Yep. Got it.
And now this happens to be in the, well, it's second order, right? Because I have a y double prime. It's linear because I was able to rearrange it into the linear form. Let's see, what other modifiers do I get to pick from once it's linear?
Non-homogeneous.
Okay.
And constant coefficient or not constant coefficient, and it is a constant coefficient.
Yep. So I get to pick whether it's homogeneous or not, and then if it's constant coefficient, I can add that modifier. So I'm going to add the constant coefficient modifier first, then the homogeneous or non-homogeneous, and in this case it's non-homogeneous, and then I'll add my ODE to the back of it. Does that make sense?
Yep.
Walkland chode.
Yep, exactly.
Yeah, Frankie.
Yeah, and if I hadn't erased it over here, I had this same form. Right.
Walkland chode.
So my coefficients are 3, 4, and minus 17. And I think you can tell me something about this thing as a spring now.
Oh, okay.
I have no idea what you just said. It cut out on my end.
I think you can tell me something about this as a spring.
Oh, at the spring.
Yeah, so second order linear constant coefficient things are springs.
Right.
Or at least can be thought of as springs. So in this case, I think I'm seeing that the mass is 3.
Oh.
The friction coefficient is 4. And the spring constant is minus 17.
And then it gets hit with the force of or at negative 84 secant x.
Good. And the external forces, right, is minus 84 secant x.
Wow. Oh, this was so long ago.
And this part, the fact that I have a spring constant that's negative.
That it goes into something? Or, no, that has...
It's damped?
Yeah.
Oh, I don't remember.
These are one of
Anti-damped. Anti-damped?
It's anti-something. I don't know whether it's anti-underdamped or anti-overdamped.
Whoa.
Oh, yeah. That got real.
It did.
That's real.
But at the very least, the spring constant doesn't lend itself to reality. Right? The spring constant should be positive.
Fake news?
Well, really more like this is a spring some kind of thing happened here that was weird. So this spring displaces towards or away from center rather than towards center.
You're drawing something that I can't see?
I'm not.
Okay.
The spring constant on this would be adding energy to the spring rather than taking it away, like a friction force.
Yeah, so the restorative force of the spring is not restoring, it's tending to exacerbate the situation. So instead of pulling the mass back towards center, it's kind of shooting it away. So if we wanted to find out whether it was kind of anti-damped or whether it was over-damped or under-damped, we could take a look at this situation here, and we really need to calculate b squared minus 4ac and see whether that's positive, negative, or zero.
Are you singing right now?
She's singing the quadratic formula.
Oh. That's awesome.
Okay, so in this case, I get 16 minus 4 times 3 times negative 17 is positive. So I'm going to have two real roots. So this is anti-overdamped. And if this came out of a real-world situation, I'm going to go look long and hard at whoever wrote down this equation and say, is it possible that you forgot to reverse the sign on the spring constant somehow? Because I am having a little bit of trouble believing that our spring system is anti-overdamped. Right? That means that as time runs to infinity, my mass on a spring is going to also run off to infinity.
Yep. If you asked us to solve this, we would use variation of parameters, right?
Yeah, if you were going to solve this sucker, you would look at it and think to yourself, okay, so it's second order linear constant coefficient, non-homogeneous, right? So yeah. I have one of three options. I can either do method of undetermined coefficients, variation of parameters, or a Laplace transform. So I'm going to look at this minus 84 secant of x, and I'm going to think to myself, is that made out of polynomials times exponentials times sines or cosines? Maybe added together? Maybe, no, it's not. It's a 1 over a cosine, right?
Yeah.
So, method of undetermined coefficients is a no-go. So then I'm left with variation of parameters or a Laplace transform. So, is secant of x a unit step function or a Dirac delta?
9.
No, it's not 9 either. It's 80. There's 84.
Yeah.
Okay. And then is secant of x on the Laplace table?
Yeah.
I'm not seeing it here. So I could try to Laplace transform it by hand, and that's going to be my go-to if variation of parameters doesn't work. But right now I'm doing like a soft cross-off on Laplace transform. Because it's not unit step or Dirac delta, and also it's not on the table. If it was Dirac delta or unit steps, then I'd have to use Laplace transform. If it was on the table, then I'd get to choose. But because it's not on the table, I'm going to go with variation of parameters, at least at first. Am I guaranteed that variation of parameters is going to work?
No.
Yeah.
Not conveniently.
Might get real gross.
Yeah, like at the worst case, I can write down that, something like the u's that you get from variation of parameters are the antiderivative of something. Whether I can do that antiderivative or not depends on the exact problem. I know that I'll get something that I'll get at least an antiderivative, and that's kind of an answer, but it's not a very satisfying one. Does that make sense? So I'm guaranteed that it would work in the loosest sense of the word work. Questions, things?
No.